Usually GCD of A and B is denoted by D is equal to A comma B. So that means the highest common factor of two numbers is nothing but it is the common divisor which divides both A and B. 12 is the common divisor which divides 60, 72 as well as 84. So HCF is nothing but the common divisors which divides the given number. HCF of fractions can be calculated as HCF of A comma C comma E divided by LCM of B comma D comma F. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to study about the highest common factors, that is the HCF of number. So we will be learning different types of solving the highest common factor as well as highest common factor of fractions and the problems related to the HCF. So let's look at what is the highest common factor. The highest common factor is also called as the greatest common divisors. Sometimes it is called as GCD. So what does it mean? So that means let we consider it as an integer D. So an integer D is said to be the highest common factor or GCD of two integers A and B. Both of them are not 0. That means here A and B are not 0. So we say D is the HCF of A and B only if D divides A and D divides B. And every common divisor which divides A and B will also divides D. Suppose if X divides A and X divides B, we say X also divides D. So usually GCD of A and B is denoted by D is equal to A comma B. So that means the highest common factor of two numbers is nothing but it is the common divisor which divides both A and B. So we have different types to find the highest common factor. The very first one is by prime factorization method. Now take an example. Let us find the highest common factor of 15 and 75. So prime factorization method, in our last class we have studied what is the prime factorization method. That means expressing the numbers in the product of prime numbers. So now 15 can be written as 3 into 5 and 75 can be written as, if you don't know to calculate or to write it directly, you can use the factorization method. So here we can write here 3 2s are 6, 1 carry, 3 5s are 15, then 5 5s are 25. So it is 3 into 5 square. Now the HCF is nothing but the product of the common factors here. So we have 3 as a common factor here. So let's write 3 and here the least power should be taken if it is repeated in both the terms. So we have 5 power 1 as the least common factor. So therefore 15 is the common factor of 15 and 75. So similarly, let's take the problem. Find the HCF of 12, 15, 18. So 12 can be written as 2 6 2 3. That is 12 is equal to 2 square into 3. Next 15 can be written as 3 5s, that is 3 into 5. Next 18 can be written as 2 9s, 3 3s, that is 18 is equal to 2 into 3 square. So what is the common factor or what is the common factor with least power in all the three terms? So clearly we can say 3 is the common factor in all the terms. So therefore HCF of 12, 15 and 18 is equal to 3. Next question. Find the HCF of 60, 72 and 84. So let us write 60 in terms of prime factorization, that is the canonical representation of 60. So 2 30s are, 2 15s are, 3 5s are. So 60 can be written as 2 square into 3 power 1 into 5 power 1. Next we'll take 72. 2 3s are 6, 1 carry, 2 6s are 12. Next 2 1s are 2, 2 8s are 16, 2 9s are 18, 3 3s are 9. So 72 can be written as 2 cube into 3 square. Next the last thing is the 84. So when you divide 84, so we have 2 4s are 8, 2 2s are, next 2 2s are, 2 1s are, 3 7s are. So 84 can be written as 2 square into 3 power 1 into 7 power 1. So which is a common factor in all the three? So here 2 square we have in 60, 2 square and 2 square. So clearly HCF is the product of the least powers containing the common factors. So here it is 2 square. Now let's check for 3. So we have 3 power 1 in all the three numbers. So into 3 power 1. So we don't have 5 as a common factor, neither 7. So it is 4 3s are 12. So the HCF of the given numbers is 12. That means 12 is the common divisor which divides 60, 72 as well as 84. So HCF is nothing but the common divisors which divides the given number. The second method is by division method, which is also called as Euclid's algorithm. So we follow the division method to calculate the HCF of the given numbers. Now let us take an example here. Find the HCF of 55 and 210. So here you should use the method of division. Now 55 3s are 165. So we are left with 45 here. Next, once you get the remainder, the divisor becomes the dividend for the next division. So take 55 here. 45 1s are 45. So 10 is the remainder. Until you get the 0 as a remainder, you should continue this process. Then take 45 as a dividend. 10 4s are 40. 5 is the remainder. Next, divide 10 here. 5 2s are 10. So we got 0 as the remainder here. So the HCF with division method is the last non-zero remainder. So we clearly can say that is 5 is the last non-zero remainder here. So therefore the HCF of 55 and 210 is equal to 5. So this process of finding the HCF is called as Euclid's algorithm. So once you take the two numbers, you have to divide the biggest number with the smallest number until you get the remainder as 0. Then the last non-zero remainder will be the HCF of the given numbers. Next, find the HCF of 45, 90, 180. So we have three numbers here. So first let us find the HCF of these two numbers, and if you find the HCF of these two numbers, then by that HCF you should divide the third one. So then you will get the last remainder as 0. Then we can conclude the given value is the HCF of the given numbers. So once you divide 45 with 90, so clearly 45 2s are is 90. So clearly we are getting 0. That means HCF of 45 and 90 is 45 itself. Now divide again 45 and 180. So 45 4s are 180. So clearly 45 divides 180 also. So which means HCF of 45 and 180 is also 45. So clearly the HCF of all the three numbers 45, 90, 180 is equal to 45. So 45 is the common divisor which divides 45, 90 and 180. The next thing is we are going to find the HCF of fractions. Now consider here A by B, C by D, E by F, etc. are the proper fractions. Then HCF is given by HCF is equal to HCF of numerators. So that means we need to take, suppose if we consider only these three numbers A by B, C by D, E by F, then HCF of fractions can be calculated as HCF of A, C, E divided by LCM of B, D, F. So we already have the knowledge of finding HCF and LCM in your lower classes here. So just we are revising the concept of these HCF and LCM once again. Now to find the HCF of a fraction, this is the method we follow. Let's take an example. Find the HCF of 8 by 9, 32 by 81 and 16 by 27. So HCF is given by HCF of 8, 32, 16 whole divided by LCM of 9, 81, 27. So HCF is nothing but the common divisors which divides all the three. LCM is nothing but a number which is divided by all these three numbers. So now to find the HCF, clearly we can see 8 divides 8, 8 divides 16, 8 divides 32. So clearly HCF of these three numbers is 8. So if you don't know to calculate, you can either use the prime factorization method or you can use Euclid division algorithm. So now to find the LCM, we know the common procedure of long division method, that is, we can directly divide this with the prime numbers or by the common factors. 9 ones are, 9 nines are, 9 threes are. Next we have 3 ones are, 3 threes are, 3 ones are. So we can write it as 9 into 3 into 3. 9 nines are 81. So 81 is the LCM which is divisible by all these three numbers. So therefore LCM of these numbers is 81. Next question. Find the greatest number which divides 39, 48 and 90, leaving remainders 6, 4 and 2 respectively. So we are supposed to find the number which divides 39, 48, 90 by leaving the remainder 6, 4, 2 respectively. So let us take the number be x. So let the number be x. So then from the given condition, x divides 39, leaving the remainder 6. That means x divides 39 minus 6. So which is equal to 33. Similarly, x divides 48 minus 4, which is equal to 44. And similarly, x divides 90 minus 2, which is equal to 88. So when x divides 33, x divides 44, x divides 88. So this implies, that means clearly x is the HCF of 33, 44 and 88. Now which is the common divisor which divides all these three numbers? Clearly we can see it's 11. 11 threes are, 11 fours are, 11 eights are. So therefore x is equal to 11. So you can't calculate this by inspection. So you can express 33 as 11 threes are, 44 as 11 into 2 into 2 and 88 as 11 into 2 into 2 into 2 as a product of primes. Then you can see the common numbers here is 11. So no other factors are repeated anywhere. So clearly the HCF of all these three numbers is 11 and hence the value of x is 11. That means the greatest number which divides all these three numbers is 11. So in today's session, we have learned how to calculate the HCF of given numbers. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.